Alright, so today we're going to, first thing, let's review what we talked about yesterday, because it'll kind of lead us into what we're talking about today pretty well. So, yesterday we talked about absolute value equations, which are pretty straightforward. Hopefully we were kind of getting the hang of those. Remember, absolute value equations, where absolute value means distance from 0. So if I'm finding the absolute value of x is 3, I'm trying to find all of the numbers that have an absolute value of 3, which are all of the numbers that are 3 steps away from 0. So if you were to start at 0 and take 3 steps, we know we could get to -3 or a +3. So on the inside of your foldable, let's just do a quick example of what we just did yesterday. So let's say we have 4 times the absolute value of v minus 5 equals 19. Now going through these steps, this is just what we did yesterday. Okay, first thing, you want to isolate the absolute value. We're going to run in that today as well, that absolute value needs to be the only thing. So that 4 is, sorry, it shouldn't be 19, it should be 16. That'll make a little bit nicer answer. Let's change the 19 to a 16. There we go. Okay, now let's try this. So if I need to get rid of the 4, to get rid of the 4, we would divide both sides by 4. We'd have the absolute value of v minus 5 equals 4. Okay, step 2, once your absolute value is isolated, you're ready to create 2 equations. Okay, and I know it was kind of a lot of steps, and it may have been kind of confusing, but you do the same thing every time. You're going to create 2 equations, one equal to the positive value, one equal to the negative value. Because remember, something has an absolute value of 4. Something's 4 steps away from 0. Well, the 2 things that are 4 steps away from 0 are 4 and -4. So your 2 equations could equal 4 or it could equal -4. What goes on the other side of your equation is whatever's on the inside of your absolute value, so v minus 5. And then you're going to solve both equations. So add 5 to both sides, you get v equals 9. Add 5, you would get v equals 1. So that's what we did yesterday. Now today's going to be similar, except today we're doing absolute value inequalities. So remember, the difference between an equation and inequality, I mean, big thing. First of all, it's not going to be v equals 9. It might be v is less than 9. So I've got like a whole bunch of answers, not just 1 or 2 answers. Okay? So for the absolute value inequalities, okay, I know we have 4 inequalities, greater than, less than, greater than or equal to, less than or equal to, but we're just going to kind of focus on the greater than and the less than part of it, okay? And then we know that if it's equal to, it means it's in close time, okay? So, here on the front here, let's start with, if I have the absolute value of x is less than 3. Remember, absolute value means distance from 0. So what this is saying is this saying I want all the numbers that have an absolute value less than 3. That's all of the numbers that are less than 3 steps away from 0. So think about it. Picture a number line, right? If you start at 0, and I said you have to take less than 3 steps, what are some numbers you could get to? You start at 0, and you had to take less than 3 steps. Do what? 1, you can take 1 step, right? Okay. 2 steps, okay. You could go to -1. You can go to -2. You could go to -2.5 or -2.75 or -2.9 or -2.9999999. You can go to 3 though, right? Because I'm equal to, okay. You could go to any number in between -3 and 3. Think about it. All of these numbers are less than 3 steps away from 0. All of these numbers, if you take their absolute value, it's going to be less than 3. Okay? Now, here's the inequality that these create. Okay? I have 2 dots. I have to have 2 inequalities. And remember from whenever we did combined inequalities last week, if I have 2 dots and I have 2 inequalities and it's shaded in the middle, what kind of inequality was this? An and inequality, right? Okay. These are the numbers, and we practiced this a little bit on Thursday last week. These are the numbers that are greater than -3 and less than 3. So some of what we do today is the same, but some of it is a little different. So let's talk through these steps here. So I'm going to talk you through the understanding, here's why it works way, and then I'm going to show you the shortcut because we all love shortcuts. Okay, let's try the absolute value of 3x is less than 15. The absolute value of 3x is less than 15. Okay, first thing, number one thing, you have to isolate the absolute value, just like yesterday. So my absolute value, the 3 is inside the absolute value, no problem there. It is isolated. Okay, next thing you're going to do, okay, just like we did yesterday, you're going to kind of ignore the fact that it's the absolute value of 3x. Just think that something has an absolute value less than 15. Okay, what we're going to do, okay, and this is like the hard, complicated way, and then I'll show you the shortcut, okay? We're going to draw a graph that shows something is less than 15 steps away from 0. All the numbers that have an absolute value less than 15. So, if I start at 0, okay, and I've got my -15, I've got my +15. First of all, I know it's a less than, so I know I'm going to have open dots. What you have to think about is you have to think about if you started at 0, and I said you have to take less than 15 steps, what are some numbers you could get to? You have to take less than 15 steps. You can take one step to the right, one step to the left. Where else could you get to? 2. 2 to the right, 2 to the left. 3 to the right, 3 to the left, right? 4, 5, 6, 7, 8, 9, all the way up to 14, but not quite to 15, right? It would be all of these numbers. What I have to do, okay, I know that 3x could be any number in here, okay? 3x could be 0, 3x could be 1 or -1, 3x could be 10 or -10, 3x could be 14 or -14, 3x could be any number in here. So we have to create an inequality to show that 3x could be any number greater than -15. Notice it's shaded in the middle, so it's going to be an and. 3x could be any number less than a +15. Okay, now, you guys want to know the shortcut? Okay, here's the shortcut, how you get from here to here without drawing the graph, okay? You're going to take this, the absolute value of 3x is less than 15. You drop the absolute value bars, okay? 3x is less than 15. That's this one right here. Okay, to get this one, you keep the 3x the same. You flip and flip. Greater than -15. See that? Okay, that's the shortcut. You're definitely allowed to use the shortcut because I know you get hard. As much as I'd love for you to understand it and explain it, I explain it so you get it, but we'll use the shortcut. Okay? Now you have to solve these. So if I divide by 3, we have x is greater than -5, and divide by 3, x is less than 5. Now, this is your answer, so you would then need to go ahead and graph your answer. So we would have an open dot at -5, an open dot at 5. Remember with the combined inequalities, the ands are the numbers that they have in common. So the numbers greater than -5 and less than 5, as we would kind of expect, are going to be those numbers there in the middle. So that would be the graph of your answer. Okay, now let's talk about the greater than absolute values. Okay, now these ones are kind of the same thing, just the opposite in some ways. Okay, so let's start here at the front where it says the absolute value of x is greater than 3. This is talking about all the numbers that have an absolute value more than 3. Okay, think about all the numbers that are more than 3 steps away from 0. So if I put you on an actual number line and I started you at 0 and I said you have to take more than 3 steps, what numbers could you get to? You have to take more than 3 steps. What are some options? 4, right? Or you go to the left and get to -4, okay? Where else? 10, or -10, 100, or -100, right? Those options, there's a bunch of them, right? As long as you are beyond 3 and beyond 3 to the right and to the left, any one of those are options. You see what this graph looks like? This is going to be an OR inequality, okay? Now, the good news is we have this nice little shortcut that's going to make our life a little easier here, okay? So let's solve this one. Let's do the absolute value of 2x minus 1 is greater than or equal to 5. Okay, now, the one thing that the shortcut does not do for you, the shortcut does not tell you whether it's an and or an or. So you're going to have to be able to understand, okay, something has an absolute value greater than or equal to 5. You have to take more than 5 steps, right? More than 5 steps, okay? Get away from 0. So these are going to be the numbers to the outsides. So we should be thinking right now, okay, this is going to be an or. Now, to come up with the 2 inequalities that you're going to solve, okay? I'm kind of a person that likes things to fit really nicely. So what you're going to do is you're going to take this exact same absolute value, okay? You're going to create 2 inequalities, okay? One of them, you just drop the absolute value marks. If you want it to work out nicely where they're on the right sides, put the first one on the right-hand side. So 2x minus 1 is greater than or equal to 5. That inequality stays the same, except you drop the absolute value bars, okay? The one that goes over here, the 2x minus 1 stays the same. You're never going to change that. But what you change is you flip the inequality sign and you flip the 5. So it's going to be less than or equal to -5. You flip and flip. Okay? Yeah, it's exactly the same as the other one. That's why I like this, because the rules are the same for both. It'll work for both of them. Okay? So, and then you just solve both of them. So we'd add 1, we'd have 2x is less than or equal to -4. Divide by 2, we have x is less than or equal to -2. Or, solve this one over here, add 1, 2x is greater than or equal to 6. Divide by 2, we have x is greater than or equal to 3. And then we'd solve each of these. So since they're both equal to's, we have closed dots both places. Now remember with the ORs, you're shading everything. So you want all the numbers less than or equal to -2, or all the numbers greater than or equal to 3. So that's what your graph would look like there. Yes? Greater than or equal to 3. Yep, greater than or equal to 3. Okay, let's get this glued into your notebook. This should be on page 33. Let's make sure we're getting our table of contents filled out. So glue into page 33. In your table of contents, these are absolute value inequalities. 33, this is still section 3.7. All right, so we will have to graph today because we're talking about inequalities. Typically, whenever we talk about inequalities, we do go ahead and graph them. So let's start with some simple ones. Number 1 says the absolute value of x is greater than or equal to 5. Okay, now, I know these kind of seem kind of abstract. It's kind of a lot to them, but use the shortcut. Okay, the first thing you need to do, the first thing the shortcut doesn't do for you, does not tell you if it's an and or an or. So this is the part you have to do for yourself. It does not matter what's in the absolute value bars. What matters is this sign here. And it says the absolute value of something is greater than or equal to 5. So think, if you had to start at 0 and you had to take greater than 5 steps, you have to decide if these would be the numbers on the insides of the 5s or the outsides of the 5s. So if you had to take more than 5 steps, would you be inside or outside the 5s? Outside, right? More than 5 steps, right? 6, 7, 8 steps to either side, okay? This is an or. If it's on the outsides, it's going to be an or. Now you have to figure out the 2 inequalities that go on either side. You do not have to make sure you put them in the right order. This is just me because I like to put things in order. So the one that you're going to come up with first, I like to put on the right-hand side because then the signs and the graphs and everything will match up nicely. The one that goes on the right side is this exact same inequality without the absolute value bars. X is greater than or equal to 5. You have to drop the absolute value bars, okay? Don't change anything about it other than the absolute value bars. The second one, the X stays the same, but you're going to flip the two sides. You're going to flip it to a less than or equal to, and you're going to flip the 5 to a negative 5. Now, if you had to solve the equation, that's what you would do here, but notice it's X is less than or equal to negative 5, X is greater, they're both solved, okay? So this is your answer, so then you would need to graph your answer. So on this graph, we'd have dots at negative 5 and 5. Since they are both equal to's, I would have closed dots both places. And remember, since it's an or, we're shading everything. All of the numbers less than or equal to negative 5, or all the numbers greater than or equal to 5. There's your first one. Yes? So it's the greater than or equal to 5. So if you started at 0, okay, and you had to take more than, greater than 5 steps, okay, so negative 5 and 5 are going to kind of be our boundary lines here, okay. If you took 1 step, that's not more than 5 steps, right? Okay, if you took 2 steps, 3 steps, 4 steps, 5 steps would work, right? 6 steps would be more than 5 steps. 7, 8, 9, 10, 11, right? All of those would be more than 5 steps away from 0. And then the other direction as well. You could take 5 steps to the left, 6 steps to the left, 7 steps to the left, 8 steps to the left. And once you come up with this graph, then you know that since it's shaded to the outside, it's going to be an or. Okay? Let's look at one that goes the other way. Okay? So this one says the absolute value of y is less than 3. Now this one, okay, let's do a little graph here, okay? So this is saying the absolute value of something, and it doesn't matter that it's just a y in there. This first part is going to be the same, okay? So if I have you start at 0, this time I say you have to take less than 3 steps, okay? So if I take 1 step, is that less than 1 step? Less than 3 steps. You could take 1 step, or 2 steps, or 2.5 steps. Could take 3 steps because it says less than, not equal to. But you could be anywhere between 0 and 3. Or you could be anywhere between 0 and negative 3. All of those numbers are less than 3 steps away from 0. And once you can picture that in your head, since it's shaded in the middle, this one's going to be an and. Does that help? Okay. Now to come up with the 2 inequalities, I like to drop the first one on the right-hand side because it stays just the same. Y is less than 3. Drop the absolute value bars, drop it on the right side. The second one, the y stays the same. Flip and flip. Greater than negative 3. Flip and flip. Okay. This one's already solved for y, so you're ready to graph this. So we've got negative 3 and a positive 3. Okay, this time they're both open dots. And I'll give you guys a little bit of a spoiler alert. If this is an and, this is always going to be an and. So you can check it, right? Greater than negative 3, less than 3. The overlap would be in the middle, but they should always match. Okay? Questions on number 2. Okay, number 3. All right, let's try one we have to solve. The absolute value of y minus 1 is less than 8. Okay, first thing you have to figure out if it's an and or an or. So if you started at 0 and I said you have to take less than 8 steps, okay? So less than 8 steps. You could do 1 step or 2 steps or 3 steps, and same thing in the other direction. You couldn't take 9 steps or 10 steps, right? You couldn't go outside the 8s. You'd have to be inside the 8s, right? You would be shaded in the middle, which means this one is an and. If it's shaded in the middle, okay? And I guess I could tell you, if it's a less than, it's always going to be an and. If it's greater than, more than, it's always going to be an or. So to figure out the two inequalities, you take this inequality, drop it on the right-hand side. Y minus 1 is less than 8. Don't change anything except drop the absolute value bars. The second one, the y minus 1 stays the same. You're never going to change what's on the inside. What you change is the inequality sign and the sign of that. So it's going to be greater than negative 8. Now this time, we do have to go ahead and solve for y. So if I add 1, we'd have y is greater than negative 7. And add 1 over here, y is less than 9. And then to graph our answers, we'd have dots at negative 7 and at 9. Since these are a greater than and a less than, we're going to use open dots. And the numbers greater than negative 7 and less than 9 are going to be those numbers there in the middle. Okay, number 4. The absolute value of a plus 3 is greater than 9. Okay, first thing, you have to decide if it's an and or an or. So if you have to be more than 9 steps away from 0, greater than 9 steps away from 0, these can be the numbers on the inside or the outsides. More than 9 steps, right? Get away from 0, right? These are going to be the numbers on the outside, which means these are going to be the ors. Okay? You're going to take your inequality, a plus 3 is greater than 9. Drop the absolute value bars, drop that one on the right side. On the other side, the a plus 3 stays the same, but flip and flip. Less than negative 9. And then to solve for a, we're going to subtract 3. A is less than negative 12. Or subtract 3, a is greater than 6. So on your graph, we have open dots at negative 12 and at 6. Remember with the ors, we shade everything. So all the numbers less than negative 12 and all the numbers greater than 6. Okay, let's do one more together. And then I'll have you try the last one on your own. Okay, number 5. Number 5 says the absolute value of 5 minus y is less than or equal to 12. Okay, first thing, we got to decide if it's an and or an or. So if you have to be less than 12 steps away from 0. Start at 0 and you have to take less than 12 steps. Would you be inside or outside? Inside, right? Okay, so this one's going to be an and. Inside is going to be an and. Okay, so we have 5 minus y is less than or equal to 12. And once again, if you put that on the left-hand side, it doesn't matter. You're going to get the same answer. I just like it because the numbers usually work out. Okay, this one, the 5 minus y stays the same. Flip and flip. Greater than or equal to negative 12. Now be careful when you're solving this one. Because to get rid of the 5, how would I get rid of the 5? Subtract. Because that's a positive 5. So I need to subtract 5 from both sides. And I'm left with negative y is greater than or equal to negative 17. I don't want negative y. I want a positive y. How do you get rid of a negative? Divide by a negative 1, but this is an inequality. Whenever I divide both sides of an inequality by a negative number, flip the sign, yeah. So it's actually going to be a y is less than or equal to 17. And then you're actually going to go through the same steps. On the other side, we're going to subtract 5, and I still have negative y is less than or equal to 7. Same thing, right? I don't want negative y, I want a positive y, and whenever I divide both sides by a negative 1, you gotta flip the sign again. So this is gonna be a greater than or equal to negative 1. Now anytime you have to flip the signs, just pay close attention to where your numbers are at. Because it's kind of worked out that I just put 17, negative 7, but that wouldn't be accurate, right? Yes. Right here? See there? I got rid of the 5. See how that negative's still there? Yeah. Yep. Okay, so make sure you put the numbers in the correct order. The -7 is going to be on the left, and 17 is going to be on the right. These are equal to's, so we'll use closed dots. And also, don't just follow the arrows. I know sometimes I see students that are like, oh, the arrow's on the outside. This should be shaded on the outside. But that's not true, because I want the numbers less than 17 and greater than -7. Those aren't the numbers on the outside, right? This is an and. These are the numbers on the inside. You can't just always follow the signs for what they kind of appear, okay? All right, last one. I want you guys to try this one on your own. I'll do what I did yesterday, so I'll kind of work it out slowly on the board. I'll give you guys a head start, and then you guys can kind of check as you go. All right, let's do the absolute value of 3x minus 4 is greater than 10. So I'll give you guys a head start, and then you can check your answer on the board when you're finished. As long as I can do it correctly today.